figure here, and the figure shows a list of different amino acids, and how these amino acids can get into the 6-day cycle. The 6-day cycle, otherwise known as the Krebs cycle, otherwise known as your citric acid cycle. So you have all these different amino acids and how they can be converted into other molecules which can then feed into the cycle. Alright? Earlier we talked about glucogenic amino acids and ketogenic amino acids. All this comes into play. Why? Because the Krebs cycle or your citric acid cycle is important for energy metabolism. You can break down energy from that, or you can also eventually possibly get gluconeogenesis from that. So you have ketogenic amino acids and glucogenic amino acids. So your ketogenic amino acids are the ones that are shown in pink in this diagram. Your ketogenic ones in yellow. So glucogenic in pink, ketogenic in yellow. So what's the difference between your ketogenic and glucogenic amino acids? Like we said before, your ketogenic amino acids, they are the ones that are eventually broken down or metabolized from acetyl-CoA, acetyl-acetyl-CoA, or acetoacetate. These ones will then be converted into ketones. Right? So these three molecules, acetyl-CoA, acetyl-acetyl-CoA, and acetoacetate, the tongue twister there, but these three, they will eventually, or can eventually be turned into ketones, which you can use for energy. Right? The others, the glucogenic amino acids, the ones in pink, those are able to be metabolized, converted into molecules, which can then feed into the Krebs cycle. So as you can see, for example, asparagine up here can be converted into oxaloacetate. This can then feed into the Krebs cycle and eventually turn into glucose. Right? So those are your glucogenic amino acids. So these ones can be metabolized, converted into Krebs cycle intermediates, and so therefore eventually can be used for gluconeogenesis. Now, based on figure 2, name 2 amino acids that are ketogenic, 2 amino acids that are glucogenic. Right? Ketogenic, any of those in yellow. Glucogenic, any of those in pink. Step B. Let's see. As you have seen, or as we've been speaking as well, certain proteins can be broken down to give you amino acids that you need for synthesizing glucose. But unfortunately, you don't always eat proteins purely for energy. Okay? So you're able to make glucose from amino acids. Does that mean that you can give up on carbohydrates totally and just eat proteins and amino acids? I'm not sure if you guys have heard, previously there was a very popular diet, the Atkins diet. They said eat all the protein you want. Eat steak, eat lamb, eat beef, eat chicken, and you'll lose weight. Don't eat carbs, don't eat carbohydrates. Now, not always the best idea. So you can use proteins for energy, but unfortunately, if you do so, a lot of the times your proteins well, they're used for synthesizing as well. You use the protein for synthesizing muscles, for enzymes, and for hormones and all these as well. If you do not eat carbohydrates, okay, what will happen is that your body will start breaking down the proteins within your body as well for energy. And when it does that, we've said before in the earlier question that your proteins in your body are required for a lot of important functions. For structure, for enzymes, for hair, for growth, and all that as well. So if you use too much of these proteins, those functions may be affected, and you could lead to possible problems with development or organ failure, and eventually death as well. So not a good idea to nutrients purely from the body without eating any carbohydrates and without eating very much else. Any questions? No? Alright. Moving on. Activity 4. If you look at activity 4 talks about the plants and the bacteria, and these are what we call autotrophic. So your autotrophic plants and bacteria, they're able to synthesize all 20 amino acids. So previously we said for humans, for animals, there are essential amino acids that you cannot produce. For bacteria, they have it good. They can produce all the different amino acids, right? Now, these amino acids, they do not make from magic. They actually do use certain backbones or certain molecules to help them to produce these amino acids. And a lot of these molecules also come from the intermediates of the citric acid cycle. So earlier we saw how some of your amino acids can be converted into molecules in the citric acid cycle, or intermediates in the citric acid cycle. A lot of your amino acids can also be formed from these intermediates as well. Okay. So how do we get the amino acids? Some of these amino acids. So you can get quite a few of these different amino acids from the PCA cycle or the Krebs cycle. If you look here, for example, you can get serine from 3-phosphoglycerate. So 3-phosphoglycerate can be converted to serine in microorganisms, and your serine can then be converted into lysine. We'll look at some of these reactions in a while as well. Okay. So it's possible to get hold and to produce all your different amino acids actually from certain molecules which we call precursors. So precursors are like the base molecule. You see these possible pathways in figure 3 to synthesize all your amino acids. So your PCA cycle is actually quite important, the Krebs cycle. Okay. One of the major precursors for amino acid synthesis and the main amino acids that give rise to other amino acids. Okay. If you see now, like we said before, precursor for serine is 3-phosphoglycerate. You have precursor for alanine, which is pyruvate. You have precursor for aspartate, which is oxaloacetate. So oxaloacetate can be converted into, or reactions can take place to change oxaloacetate to aspartate. Aspartate can then be turned into asparagine. So you get certain key amino acids which can then be converted into other amino acids as well. Right? So here you have alpha-ketoglutarate, this orange pink block. Alpha-ketoglutarate is the precursor for glutamate. Alright, this is a reaction we'll be talking about quite a bit later on as well. Alpha-ketoglutarate can be reacted to form glutamate, so that is one of the base amino acids. Okay. Glutamate can then be converted into proline. You can get glutamine from glutamate. You can get histidine from glutamine. So you can actually get histidine if you have glutamate back. Right. Similarly for arginine. So in this case, alpha-ketoglutarate is the precursor for glutamate, which can then be turned into these different amino acids. Alright, there's one group here. Oxaloacetate is your precursor for aspartate, and from aspartate you can get asparagine, lysine, methionine, threonine, isoleucine, valine, and leucine. Sorry? Aspartate? Yes, aspartate. Certain forms of aspartate. So the way the amino acid is arranged, that actually aspartate is used to form a molecule called aspartame. Aspartame or aspartame. That is an artificial sugar. Yeah. So aspartate is an amino acid. Aspartate can be used to form other molecules such as aspartame. One error, just now, sorry everyone, I mentioned that you can get from oxaloacetate, you can get leucine and valine. You can't actually get leucine and valine. You get leucine and valine from pyramid. So that was me being a little colorblind there, sorry. Yes. Yep, so the question was, just now we mentioned artificial sugar, aspartame. Aspartame is one of the chemical sugars that you can add to coffee to make it taste sweeter. Aspartame is produced from aspartame. So basically, like we said before, these are your precursors, oxaloacetate, alpha-ketoglutarate, from all these other groups of amino acids there. Alpha-ketoglutarate, precursor for glutamate, you can get these other ones. Oxaloacetate, mentioned here, precursor for aspartate, you can get all these other amino acids. Pyruvate, alanine, leucine, and valine. 3-phosphoglycerate, further up just now, serine, and from serine you can get glycine and cysteine. And even further up, phosphoenolpyruvate, PEP, which you can get phenylalanine from. Tyrosine and tryptophan. So you can actually get all your amino acids from your PCA cycle intermediates or your Krebs cycle intermediates. But this only happens in microorganisms. So for example, your bacteria. Animals are not able to produce some of these ones. We don't have the enzymes that can help us produce these.